Alright, so today's lesson we're going to be continuing on with verifying trig identities. It's a little shorter, but it's still a good lesson. So if you remember when we did these kind of problems, sine of the inverse cosine of 3/5? We did these kind of problems when we were talking about inverse trig functions. And we said that this is going to give us an angle. Inverse trig always gives us an angle. So we could actually draw a triangle whose angle, the cosine of that would be 3/5. Another way to think about this is inverse cosine is an angle. We take the cosine of both sides. All right, so the cosine of that angle is 3/5. We just drew that triangle. So what's the sine of that angle? Well, using Pythagorean theorem, you get 4, so the sine would be 4/5. The sine of the angle you get from the inverse cosine of 3/5 is 4/5, right? So let me show you what this looks like. We did this kind of stuff before, but let me show you what it'll look like in this section. I'll ask you to verify that the secant of the inverse tangent of x is equal to the square root of x squared plus 1. Actually, the secant of the inverse tangent of x, is the square root of x squared plus 1. So this is going to give us a triangle. Let's draw a triangle whose angle if you take the tangent of both sides, that's going to tell us to draw a triangle whose angle, theta, the tangent of that angle is equal to x over 1. All right, tangent is opposite over adjacent. If tangent's x, it would have to be x over 1. Well, when you take the secant of that triangle, you should get the square root of x squared plus 1. So let's double check. Pythagorean theorem would say that 1 squared plus x squared is your hypotenuse squared. X squared plus 1 would be your hypotenuse squared. Your hypotenuse would therefore be the square root of x squared plus 1. All right, so really the answer is just in the work here. If you take the secant of that angle, the secant would be the hypotenuse over the adjacent, which is exactly what we wanted. All right, we'll do one more. What about verify that the sine of the inverse cosine of x is equal to the square root of 1 minus x squared? Well, remember, this is going to give us a triangle. And inverse cosine gives us an angle, so the angle would be the inverse cosine of x, or just the cosine of whatever angle gives us x over 1. So here's an angle, and according to that inside piece, the cosine of that angle would be x over 1. So now let's figure out what the sine of that angle would be. Using Pythagorean theorem, we'll call this side like y for now. X squared plus y squared is equal to 1 squared. Trying to get the y by itself, we're trying to find that missing side, would be 1 minus x squared, and y would be the square root of 1 minus x squared. Right? So what's the sine of that triangle? Well, the sine would be opposite over hypotenuse, which we just showed, right? So everything works out. The sine of the inverse cosine of x would equal square root of 1 minus x squared over 1. That's exactly what we had to show, and we just showed where that came from by drawing the picture. All right, so stay tuned for the homework. What I'm going to ask you to do, this is just title, we'll call it homework or classwork, will be worksheet number 3. All right, good luck. Have a nice day.